A problem from the text asks if we have a 10 kilogram block sitting on a 20 kilogram block sitting on a table, then what's the normal force exerted by the table and what's the normal force exerted between the two blocks? How do these forces come about and how large are they? Well, let's go back up here for a second. If we think about it, the table is supporting both blocks essentially. So if we regard the two blocks as one entity, there's 30 kilograms pushing down on the table, and there's an elastic force in response to that 30 kilogram push. The table bends a little bit and pushes up with a 30 kilogram elastic force. And that's the normal force that's exerted by the table against the total block, the total of the two blocks. Now, I think I said something about 30 kilograms of force. It's late and I'm starting to get a little bit funny here, and I apologize for that, but I really need to get this done, so please bear with me. Let me clarify. It's the force of gravity on the 30 kilograms, which is going to be approximately, well, it's going to be 294 newtons of force. So the table will have an upward force of 294 newtons. Now let's see more specifically how that comes about. If we just look at the forces on the block, we have a normal force exerted by the table on the 20 kilogram block. We have a gravitational force of 196 newtons, the 20 kilograms times 9.8 meters per second squared, acting downward. And we have 98 Newton force. That's a contact force with a 10 kilogram mass. Because if we look up here again, we can see that since the 10 kilogram mass isn't going anywhere, it has a 98 Newton downward force from gravity. There must be a 98 Newton upward force, and the only thing in contact with it's a 20 kilogram block, so it must be exerting a 98 Newton upward force. If the block exerts a 98 Newton upward force, the 20 kilogram block exerts a 98 Newton upward force, then by action and reaction, the 10 kilogram block must be exerting a 98 Newton force down. So there's a contact force of 98 newtons between the two masses. The normal force has to balance the net of these two forces. These are all the forces that are acting on the 20 kilogram mass, and they have to be in balance because everything is standing still, meaning it's in equilibrium. The only conclusion then is that since there's no net force, the magnitude of the normal force minus the 196 Newton downward force of gravity minus the 98 Newton downward contact force of the 10 kilogram object must be 0. We solve for n, we get 294 newtons. Now again, if we look at the 10 kilogram mass, we see this normal force being exerted by the 20 kilogram object, the contact force, and a 98 Newton downward force by the weight. Since this is in equilibrium, we conclude that the normal force on the 10 kilogram mass has the property that its magnitude minus 98 newtons is 0, so that the magnitude of this normal force is just 98 newtons.